Okay, we're looking at solutions to the problems on page 537, and this is the homework from 429. We're going to look at number 9 now, and it's asking us to use table 14.2. So table 14.2 is on page 525. So you're going to look at this on page 525, and it's a table of KEQ data. Okay, KEQ data. So basically equilibrium constants, and they're equilibrium constants for reactions at different temperatures, at different temps. Okay, you can see that they change. So they ask us for part A. They want to know for 2HI forming H2 plus I2 at 250 degrees C. So I'm going to look at my table. I'm going to look at my table at H2I2 forming 2HI. So they're giving me the reverse reaction at 250. Okay, what they're telling me in the table is that this reaction here forming 2HI at 250 degrees C, the KEQ is equal to 113, which is much greater than 1. Okay, which means that the KEQ for the reverse process, if I was going to flip this around, the KEQ would be much less than 1. Okay, so if KEQ is much greater for this forward process, then the opposite reaction would have the KEQ much less than 1, and so we can expect for the reaction that they're asking us about, it would look something like much less than 1. We'd end up with lots of reactants, okay, and very little product at the end. Okay, this is at equilibrium. So determine whether the following equations favor the forward or the reverse. Well, what you would say is it favors the reverse for part A. If we look at B, they want us to look at N2 plus O2 forming 2NO. Okay, if you look in the table at 25 degrees C, the KEQ for that process is 4.5 times 10 to the minus 31, which is much less than 1. Okay, which is much less than 1, which means this reaction favors the reverse process. Favors the reverse process. If I look at C, N2 plus H2 forming ammonia, they want to know at 25 degrees C what the KEQ is. N2 plus H2 at 25 degrees is 3.3 times 10 to the 8th, okay, which is much greater than 1, which means this favors the forward process. Favors the forward process. Part D, they ask us for, again, the same reaction, but at 527 degrees C. And if I look in the table, at 527 for that reaction, it's 3.8 times 10 to the minus 2. And this is less than 1, and so this favors the reverse process. And so you can see by comparing C and D, temperature has a big effect on equilibrium. At the lower temperature it favors the forward, but at the high temperature it starts to favor the reverse process. And then E, dinitrogen tetroxide forming 2NO2. Again, if you look in the table, at 55 degrees C, they're telling us 2NO2 forming N2O4 is 22.6 KEQ is equal to 22.6, which is greater than 1, okay? But we want to know for the reverse process for N2O4 forming. So that means I'd have to flip this around and I would find that K is less than 1, which means this reaction favors the reverse process. Okay? So in this case, please remember that if they give you the reverse reaction, okay, of what's provided in the table, you have to flip around the KEQ. Okay, and so in the case for KEQ, for example in A, the value reported in the table was for this reaction here, okay, and it was greater than 1. Well, we actually wanted to know the KEQ for this, but they didn't provide it in the table, so I have to infer from what's provided in the table what the KEQ would be. And so the table value is greater than 1, so I have to infer that it's less than 1 for the reverse reaction.